Okay, so next is we want to study on the important properties of the ROC for the Z transform. Previously, we have seen the example of finding ROC for both finite and infinite signal. And for both signal, actually, we will have three types, which is non-causal or two-sided signal, causal, which is n that is always in positive range, and lastly the anti-causal, where the n is always negative value. The important point here is for the two-sided signal, the ROC is entire z-plane except z equals to 0 and z equals to infinity. For the right-sided and left-sided signal, we will see after this what is the difference with the causal and anti-causal signal. So this is the causal signal, and this is the right-sided signal. As we can see here, for the right-sided signal, there are many signals at the right-sided, and also we also have the value at the negative range of n. So actually this signal of right-sided is also in the group of two-sided signal. So that's why the ROC is entire z-plane except z equals to 0 and z equals to infinity. And next is we will see the difference of left-sided and the anti-causal. So for the left-sided here, we can see there are a lot of signal at the left side, okay, and also we have the signal at the positive range of n, and again this signal is two-sided signal. So that's why the ROC for the left-sided signal, which have the signal at the positive range of n, the ROC will be this one, the entire z-plane except z equals to 0 and z equals to infinity. Okay, this is for the infinite properties for the ROC. Okay, the important part is when we have two-sided, the ROC will include the intersection of the ROC of the components. Okay, this is again for the infinite, we have three types of signal: two-sided, anti-causal, and causal. Okay, so we will see the example of infinite signal after this slide. Okay, so this is an example of ROC for three types of signal, where we have causal, anti-causal, and also the two-sided signal. This is two-sided signal or non-causal signal. Okay, so this example we have seen previously how to calculate the Z transform for the UN. The additional is we have the amplitude scaling here, where we multiply the unit step with 0.5 to the power of n. And you can check here how I simplify the equation here until I get the Z transform, Z over Z minus 0.5. And this one at the denominator, this is the location of our poles. Okay, this one we have Z minus 0.5 equals to 0. So our Z is equals to 0.5. And the value of Z is positive. So that's why we have this range which is larger than 0.5. Next is for anti-causal. Before we can calculate the Z transform for this signal, you must know how to draw the U negative n minus 1. There is two methods, which is the first one is you do the scaling, the time scaling, and then you do the time shifting. Or another way is you do the time shifting and then you do the scaling, the time scaling. So both you will get this signal. So for example, I want to use this method. First I do the time scaling and then I do the time shifting. So for example, we have un from 0, n equals to 0 until infinite. So this is un. And then for the time scaling, I have u negative n, which is I reflect the signal at n equals to 0, and the positive range will become the negative range n. So this is the location of n equals to 0. Okay, next is I do the time shifting, which is u negative n plus 1. Okay, so for u negative n plus 1, for example here, the list will be from negative infinite. I have the value of 1 until at n equals to 0. So for n plus 1, actually this one, the marker here will be moved to the positive side. Okay, so the value will be here 0. Okay, so the new signal will be from negative infinite, and I have the amplitude of 1 until at n equals to 0, I have the value of 0. So this is the new location of my marker. So this list actually is equal to this graphical representation. Okay, after you know how to represent this signal with the numeric sequence, then you can get the margin of the summation here. So for example, here we have n equals to negative infinite until negative 1. Okay, so this is n equals to negative 1, xn z negative n. For unit step, the xn amplitude will be equals to 1. Okay, and we multiply with z negative n. To use this theorem, okay, I need to simplify my equation in the form of alpha to the power of k. So when I simplify here, okay, because this is in positive range, I change the negative range into positive, where you can see here, my n here become negative n. If you expand the equation, it will be the same as at the left side here. Okay, so for example here, z minus 1 minus 1. So actually it will give you the value from here. Okay, so this equation at the left side and at the right side is similar. Okay, after you simplify into this form, okay, n equals to 1 until infinity, z to the power of n, so our alpha is equal to z, and we can use this equation and replace the alpha value with z. So we have z divided by 1 minus z. Again, at the denominator is our location of poles. So the location of poles is here, and the z is smaller than 1. Okay, the z is smaller than 1, that's why we will have this ROC. The ROC is inside the circle. Okay. And lastly, for the non-causal signal, we have the summation of the causal signal and the anti-causal signal here. Okay, so I simplify this equation, and at the denominator we have the location at z equals to 0.5, and also z is lower than 1. So for example here, z larger than 0.5, this is the ROC, including the infinity. And then we have the ROC, which is inside the circle with radius 1 here. Okay, so for the ROC of infinite signal with the type of non-causal or two-sided, it is the intersection between the two ROC. So as we can see here, the intersection is at the one that we have two lines here. Okay, so this is our ROC for non-causal signal. For this slide, this is the summary of ROC. The first one is for the finite signal, okay, and this is the ROC for the infinite signal. Okay, and lastly, I summarize the ROC. As the conclusion, for the ROC, we have two types of signal, the finite and infinite. The finite means we have the value with bounded n, okay, and for the infinite, we have value that have no ending, the signal that have no ending. So for the finite, we have three types, which is causal, anti-causal, and two-sided. For the causal, the ROC is entire z-plane except z equals to 0. And for anti-causal, we have entire z-plane except z equals to infinity. And lastly, for the two-sided, we have entire z-plane except z equals to infinity and z equals to 0. Okay, so actually you can just memorize the type of signal and the ROC. Okay, next is for the infinite. Okay, for the infinite, we have also three types, which is causal, anti-causal, and two-sided or non-causal. Okay, for the causal, the ROC is z larger than the radius. For example, if at the denominator we have, for example, 1 over z minus 3. Okay, so our ROC is z larger than 3. The A value is 3. Next is for the anti-causal. So for example, if we have 1 divided by 2 minus z, so our z is equals to 2, and the value of z is lower than 2. That's why it is in the circle. So the A value here will be equals to 2. And for the non-causal, it is intersection between two ROC, and usually it is in the form of ring. Okay, to check whether you have understand the ROC concept, we look at the example 5.2. First, when we have the question, we need to check whether the signal is finite or infinite. Okay, for example here, since we have a limited signal, there's no infinity here, and the range we have n equals to -3 until +3. So this is the finite signal. Next is you need to check what type of signal. Okay, whether it is anti-causal, it is causal, or non-causal. Okay, as we can see here, the signal involves the negative range and the positive range. This is two-sided signal or the non-causal signal. Therefore, the ROC for finite and non-causal signal, so you can just refer to this slide. For the finite, this one, and it is two-sided, the ROC is entire z-plane except z equals to infinity and z equals to 0. Next question is, we have this signal. Again, we need to check the signal whether it is finite or infinite. Okay, since again this is bounded signal, so this is finite. And next is we need to check the type of signal, whether it is anti-causal, causal, or non-causal. Since our signal is at the positive range, so the positive range of n is causal signal. Okay, so the ROC for the finite and causal is entire z-plane except z equals to 0. Okay, so this is the answer. Okay, next is the exercise 5.1.